Hi, my name is Josh Haynes, and I am a part of the team Everyone Else. I will be going over my individual progress reports for sprints 1 and 2. My primary focus for sprint 1 revolved around the inventory panel. Two of my child user stories were, as a gamer, I want an inventory to be displayed so that I can easily see which items have been collected, and as a gamer, I want a specified number of chips to be displayed so that I know how many are needed to complete the level. The inventory panel as a whole has 5 main sections. It consists of 3 J panels, 13 J labels, and 3 J text fields. The first child user story on this slide is specifically referring to the boots and keys sections, which have their own J panels. These sections have 5 J labels each, 1 label to describe the section and 4 additional labels to hold an image of the appropriate boot or key based on whether or not they've been collected, which they get collected by collisions between the gamer and those collectible items. The inventory panel class exposes the ability to enable or disable the boot images. The second child user story on the slide refers to the chips left section of the inventory panel, and this section consists of 1 J label and 1 J text field. And on the first diagram to the left, that's the actual inventory panel. I've drawn arrows and shown where the J labels are and where the J text fields are. And the class diagram to the right, that is of the inventory panel. It shows the accessibility, it shows the properties and the methods of this class. The third child user story I had in Sprint 1 was, as a gamer, I want a timer to be displayed so that I know how much time I have to complete the level. This is specifically referring to the time section of the inventory panel. The diagram to the right describes this functionality. So when it starts, it will load the game data for the level with its default time value. It will display a main window with the inventory panel and create a thread and wait for the gamer to press the spacebar. Once the gamer finally presses the spacebar, the game will process the animation logic and check to see if 1 second has passed. If 1 second has not passed, then it will continue to process the animation logic. If 1 second has passed, then it will subtract 1 from the time in the game data and update the inventory panel. It will then check to see if time is greater than 0. If it is, then it will continue to update the timer, but if it is not, then it will stop updating the timer. For Sprint 2, the first child user story I had was, as a gamer, I want to be able to walk over a portal tile when I have collected all chips in the level so that I can complete the level. So to start off with, a portal tile gets drawn onto the game panel when the game data loads its levels immovable objects. And ultimately, a portal tile is an immovable object by inheritance, as shown in the class diagram. The portal class has its own collide method, which is an override of the game object's abstract method. This method is what happens when a gamer walks over a portal tile. The flowchart to the right of the class diagram shows the process. Basically, the level is in progress, the gamer moves over the portal tile, and evaluation is done to see if there are more than 0 chips left. If there are, then there's nothing to be done. But if there is 0 chips left, then the level completion banner is displayed. The last child user story for Sprint 2 is, as a gamer, I want to be able to walk over a green button on the ground to cause a special wall to open or close so that I can progress throughout the level. So as you can see from the class diagram to the right, the toggle wall is a special kind of wall, which ultimately is a game object at its root. It inherits everything from wall, but extends the functionality. The toggle wall has an opened and closed state. It exposes the ability to switch between those states by providing the setOpen method. Button is another object type that I wanted to include here as well because it is what triggers the toggle wall to toggle. Button is set up in a way that you can pass an array list of game objects to it and do what you want with those objects when the button becomes pressed. Button also uses an enum type called button type. For this user story, I implemented the scenario when the button type is green. So when the button type is green and the button becomes pressed, then all associated toggle walls will become closed if they are open and open if they are closed, simply by calling the toggle walls set open method. And that concludes the user stories for my individual progress report for sprint 1 and 2. Thanks.